Alright, so our group number 6, right? Maybe. But anyway, so group work. The number 1, part A, we need to find the parental offspring, and then which is the agouti, wild type, and mahogany. Wild type red and wild type, and then I wrote the gene symbols, and then I found from there the arrangement is the wild type red, wild type over agouti, wild type, and the mahogany. The part B, we need to find the double crossing overs, which is the list amount of the data. Then I found the agouti, red, and wild type, and then wild type, and mahogany, which is the 1 each. Then I wrote the possible gene order for that, and then I found that the middle, this red circle one order is the right one. Part C, I need to find the distance between red and then agouti genes, and then agouti genes and the mahogany genes. I did the single crossing overs for this, and then find the genotype of them, and then from the data I pull up the numbers, and then for the RG and then A, I got 17.48 map unit. Then the A and MG ones are the 13.11 map unit. So this is my answer for part C. And then part D, I need to find what is the crossing overs for the double crossing over frequency. Then times the total number of that frequency, I got a 4.738, and then my value is 1 minus 2 over 4.738, which is 0.578 or 57.8%. Okay.
So number 2 is honestly the exact same setup. In this problem we're looking at Drosophila, specifically the scute bristles, the sable bodies, and the vermilion eyes. So those are linked and recessive. Anyway, so again, it's the same setup. So for A, we're trying to find the gene arrangement for the 3 linked alleles, which is right here, and that we put up there. And then for B, we're trying to find the possible arrangements, and then which ones actually work. And so we circled the one that does work, which is this one here. Then C is when we're just trying to do that linkage map, which is again where you're looking at that chart, which is here. So it's pretty simple. You're looking at the numbers, adding it. I always start with the recessive numbers because those are constant, so it's just easy to start there first, and then you put it over and then you add all the variables, because it'll change based on which traits you're looking at over the total, multiply it by 100, and that'll give you your units, and then that gives you your little map. And then in order to get the interface value, we're going to do for D, we do the same thing again that Cyan is doing, and which is where you take the 1 minus 24 over 33, and that's going to get you 27.31%. I mean, it will start as a decimal, then you just convert it over to the percentage. And then I think Abby is going to explain number 3.
link well. So I chose for my wild types to just do WT, and everything else is just lowercase. So for A,
Yeah, go for it.
you needed to determine the gene arrangement, and you get that from the two dominant. So you get the C and then two wild types, and then for the other side you get the G wild type S. And then for B, you figure out, you have to arrange it correctly, put it in the gene order, which is going to be wild type C, wild type, and G wild type S. And then for C, the two that were our double crossovers are 0 of each one. And so that's kind of a trick question. So then you take the crossover of that, you get 24 and 29. Add those together divided by 1,000, and you get 5.0 or 0.056 times 100 equals 5.6 MU. And then for the second half, the same thing. You get 8 and 11, which is going to be 1.9 MU. And then for D, you take the 1.9 over 100, or divided by 100 times 5.6 over 100, which equals 1.66 times 10 to the negative 3. And then you multiply that by the population, which is 1,000, you get 1.06, and then do the 1 minus 0 over 1.06, which is 100%, is going to be the interference value.
Ready? Alright, so for number 4, as like we did for the last 3, part A, we need to find the parental offsprings, and then get an arrangement of this. Then part B, find the double crossing over ones, which is the least amount, and then write the possible gene orders for that, and then I found that this one is the right one. And part C, I found the both distance between the AN and F, and then the F and BR, and then I found this, and then add up together to the single crossing over and the double crossing over divided by the population times 100, which is 19, the mapping unit, and then this one also add up all together divided by 1,000 times 100, which is 5.1 map unit, and then this is my answer. And part D, so 19 mu divided by 100 times 5.1 map unit divided by 100, which is 9.69 times 10 to the negative 3rd. Multiplied by the population, which is 9.69. The interpret value is 1 minus 5 over 9.69, which is 49.8%.
Alright. And how do you want to explain this last one? Do you just want to do it together?
Together.
Alright.
Okay.
So I'll just hold this, I guess.
Right.
So for this last one, just sort of looking through the text on it. And so we're kind of looking at how it just seems to be dependent on whether or not it's
It's like crossing over or not.
yeah, crossing over or not. And so sometimes they do and sometimes they don't. And so it'll be, so that first one's going to be 50-50, right?
Yeah, if it's not crossing over, then 50-50 for the
Mm-hmm.
dominant A, recessive A, and then dominant B, recessive B.
Mm-hmm.
And if the crossing over occurred, then same as the dominant A, recessive B, dominant B, recessive B, and then dominant A, recessive B, dominant B, and recessive A.
And then for D, it was just reverse. It was just algebra, really. Like, we just did the reverse of the math, right? For D. Sorry, for D.
Oh yeah.
Of what we would normally do.
Yeah, but I think we are just going to the B.
Oh, sorry. Yeah.
Okay, so
Moving ahead.
So if you look at B, it's just crossing over. Oh, it does not occur. So you're gonna get the 50% homozygous for A and B, and then or dominant, and then 50% recessive homozygous.
So then C, we are crossing over to the same situation as B. So we will get the homozygous of dominant, homozygous recessive, and the heterozygous for each of them. Then the last part, we knew that the distance between dominant and recessive alleles are 7.8, and then we divide by 100, and then we will get the 7.8% of the frequency.
Yeah, and I think that's everything.
Okay.
All right.